In this course, we will cover principles of managing drone traffic and coordinating flights. In addition, communication techniques with drone operators and incident command will also be reviewed. The learning objectives include identify when, where, and how to conduct aviation radio communications. Describe roles and responsibilities of key UAS personnel. Apply the use of checklists. Identify ways to implement a risk assessment. Let's talk about some of these best practices. Crew Resource Management, or CRM, is the effective use of all available resources, human, hardware, and information, prior to and during flight to ensure a successful outcome of the operation. The remote pilot must integrate crew resource management techniques into all phases of the drone operation. Many of the crew resource management techniques traditionally used in crewed aircraft operations are also applicable for drones, such as the ability to delegate operational tasks and manage crew members, recognize and address hazardous attitudes, and establish effective team communication procedures. The remote pilot identifies, delegates, and manages tasks for each drone operation. Tasks can vary greatly depending on the complexity of the operation. Supporting crew members can help accomplish those tasks and ensure the safety of flight. For example, visual observers and other ground crew can provide valuable information about traffic, airspace, weather, equipment, and aircraft loading and performance. The remote pilot assesses the operating environment. This includes airspace, surrounding terrain, weather, and hazards. Determines the appropriate number of crew members that are needed to safely conduct a given operation. The remote pilot must ensure sufficient crew support so that no one on the team becomes overtasked, which increases the possibility of an incident or accident. Informs participants of delegated tasks and sets expectations. Manages and supervises the crew to ensure that everyone completes their assigned tasks. A drone operation may involve one individual or a team of crew members. As a review, Part 107 defines the following crew roles. Remote pilot in command. A person who holds a current remote pilot certificate and has the final authority and responsibility for the operation and safety of the drone. Person manipulating the controls. A person controlling the drone under direct supervision of the remote pilot in command. Visual observer. A person acting as a flight crew member to help see and avoid air traffic or other objects in the sky, overhead, or on the ground. Site manager. A person responsible to ensure all safety rules are followed and to assist the remote pilot with aircraft separation and crowd control if needed. Air boss, responsible for deconflicting multiple aircraft operations. Provides a safety and security resource for all the pilots and crew as an additional safety supervisor. A crew briefing is likely something you have heard about as a best practice. Before any drone operation, at a minimum, ensure that all persons directly participating are informed about operating conditions, emergency procedures, contingency procedures, roles and responsibilities of each person involved in the operation, and potential hazards. Now we'll spend some time discussing communication. The FAA requires that the remote pilot in command and other crew members should coordinate to scan the airspace in the operational area for any potential collision hazard and maintain awareness of the position of the drone through direct visual observation. To achieve this goal, the remote pilot should foster an environment where open communication is encouraged and expected between the entire crew to maximize team performance. They should establish effective communication procedures prior to flight, including selecting an appropriate method of communication, such as the use of handheld radio, cell phone, or other techniques appropriate to the operation. It is also important to inform the crew as conditions change and make any needed adjustments to the communication plan to ensure a safe outcome of the operation. When using a two-way communication device, here are some basic communication procedures. Listen before you transmit. Think before keying your transmitter. Place the microphone close to your lips, and after pressing the mic button, speak in a normal, conversational tone. Be alert, both to sounds as well as a lack of sounds, which could indicate lost or broken communications. After too long, silence should be suspicious. Be sure that you are within performance range of your radio equipment and the ground station equipment. These methods are useful for both communicating with your crew and with other entities, such as air traffic control or other pilots in the area. Even when operating a drone, there may come a time when you are required to maintain radio communication with air traffic control. When making an initial contact with an air traffic control facility, there is a proper format of communication. State the name of the facility being called, followed by your full aircraft identification as filed in the flight plan or as discussed in paragraph 424 called Aircraft Call Signs in the Aeronautical Information Manual. When operating on an airport surface, state your position. You can include a brief statement to indicate the type of message to follow or your request if it is short, and use the word over if required. It is recommended that remote pilots understand radio communications of crewed aircraft in their flight area. Things like knowing the local frequencies of nearby airspace and airports beforehand can help in the event of an encounter with another aircraft. Of course, that won't do you much good without a means to communicate. Therefore, it is good practice to have a radio that will allow the remote pilot to monitor aircraft radio communications. It is important to know the range and limitations of your receiver and transmitter. For instance, even if you can hear radio communications, your transmitter may not have the strength to broadcast a legible message to those on the other end. As such, unless there is an emergency, the remote pilot should refrain from transmitting over an active aviation frequency. Some types of frequencies that may be useful to a remote pilot and can be found on aeronautical charts are Common Traffic Advisory Frequency, or CTAF. This is indicated on an airport's title block on the charts by a dark blue circle with a C, and means that an airport uses the CTAF, which allows passing pilots to self-announce their location and intention. When included at a towered airport, this implies that, although the airport has a control tower, it may only operate part-time. ASOS and AWOS are frequencies connected to weather reporting systems which automatically broadcast aviation weather recordings. They are different systems but provide the same general information such as barometric pressure, wind speed and direction, visibility, and precipitation. Unicom frequency. When scanning for communications, it would be best to monitor both the airport's Unicom and CTAF channels. Some other basic frequencies include those listed on the screen. 121.5 MHz is an emergency frequency. If there is an emergency, pilots will transmit on it. 122.750 MHz is for general aviation air-to-air communications. 123.025 MHz is for helicopters air-to-air communications. 123.450 MHz is an unofficial frequency for air-to-air communications. 122.0 to 123.65 MHz is a range for Unicom and air-to-air communications. 128.825 to 132.000 MHz is a range of frequencies for airlines, corporate aviation, and general aviation, calling ahead for fuel, parking, and other requests. The goal of risk evaluation is to proactively identify safety-related hazards and mitigate the associated risks. One way to look at risk is on the individual level using the PAVE model. PAVE is an acronym for risk evaluation. P is for the pilot in command. Think back to the acronym, I am safe. What does I am safe stand for? If you said illness, medication, stress, alcohol, fatigue, and eating, you would be correct. This is, in essence, your readiness checklist. A is for aircraft. What limitations will the aircraft impose on the mission? Is this the right platform? Are you familiar and current in this aircraft? V is for environment, including weather, airspace, and terrain. And lastly, E is for external pressure. This creates a sense of pressure to complete a flight, and often at the expense of safety. Pride can be a powerful external factor. So, how do we make this usable for you as a pilot? A best practice is the use of a Flight Risk Assessment Tool, or FRAT. The image you see on the screen is just one example of a risk assessment form. There are also apps available as well if you want to be digital. The idea of a FRAT is to identify key elements of typical flight hazards and combine them to make assessment easier. With most FRAT tools, you are assigning a numerical rating that leads to a go or no-go designation, but your systematic critical thought process should not end there. You should constantly be assessing and reassessing the factors. Now let's take a look at the FRAT used at NC State University. It is available to you as a resource. On the left-hand side of the form, you have three functional groups: operational factors, pilot and command factors, and environmental factors. Within each group, you have potential hazard or risks. Each one is then assigned a score from 1 to 5. You will come up with a total score that falls into either a low, medium, or high-risk category. Using this FRAD example, it is not likely that your pilot and command factors will change during the flight, nor will many of the operational factors change. However, the environmental factors, such as the forecast and wind speed, can absolutely change without much notice. Also keep in mind that just because a flight is assessed at a score of 28, making it fall in the low range resulting in a ghost status scenario, doesn't mean the risk is truly low. What if you are tired or aren't as comfortable flying that particular aircraft? There are many factors to keep in mind before and during the flight. Safety and mitigation are paramount. Being diligent about mitigating risks will help to prevent emergencies, and as an air boss, this is important. Some good reminders include situational awareness and decision-making, safety, contingency planning, identify the issues, evaluate system status, aircraft control, execute emergency procedures, and land the aircraft. One way to synthesize all of your best practices is to use a checklist. A checklist is a compilation of items required, things to be done, or points to be considered, used as a reminder. Checklists counter the "don't tell me" and do it quickly hazardous mentalities outlined by the FAA by requiring all pilots to follow consistent procedures as opposed to making decisions based on opinion, feeling, or instinct. There are different types of checklists available. A deployment checklist can be used to ensure all equipment, maintenance material, documentation, and personal protective equipment is available and in good condition. Some items might have long lead times, for example, charging batteries or applying for waivers. It is also a good idea to have containers for your equipment with labels. And consider standardizing the location of maintenance materials like tools, tape, and glue. Another type of checklist is from an operational perspective. It can include pre-flight, in-flight, post-flight, and emergencies. The pilot should know what is on the checklist by memory. The checklist is still used to make sure all steps were followed. Checklists are device-specific, even to the individual aircraft. Pilots and visual observers should be familiar with all checklists before flight. Checklists are often incorporated into the drone flight software or into third-party flight management software like Drone Logbook as an example. When thinking about pre-flight checklist items, you should consider checking the flying conditions and the itinerary, securing the necessary documentation before the drone operation, knowing and complying with specific drone operational laws or policies in your area, ensuring if the drone equipment is ready for flight, and always update your firmware. Sometimes it may be easier to use an actual piece of paper in front of you versus solely relying on electronic formats. If you are utilizing your phone as a display connected to your controller, then it will be difficult to refer to any checklist that may be stored on the phone. This is an example of an aircraft checklist. You can see it includes pre-flight, has emergency checklist items, and is also tied to a specific aircraft. This one's for the DJI Mavic Pro. It also includes operating limitations and specifications for aircraft. Lastly, it is important to update your checklists. They aren't static documents and should be reviewed and updated as needed. This could be whenever there are equipment changes, software updates, new regulations, policy changes, or additional training requirements. All of these best practices are going to help you with your mission area assessment. This includes: first, think about the authorizations required. You need to determine what provisions you are flying under, either Part 107 or a Certificate of Authorization referred to as a COA. Section 333 is an exemption in connection with a Certificate of Authorization. This is more common with public safety. The Certificate of Authorization is granted through the FAA. A NOTAM is a notice to pilots about any flight restrictions, also referred to as a TFR or temporary flight restriction. Some states, like North Carolina, do require an additional permit to be able to fly. It is important to know the expectations of a particular area. You need landowner approval, even when flying during an emergency. Second, check the surrounding area for obstacles. This includes takeoff, landing, and the mission area itself. It is also important to identify an alternative landing location. If there is time, ask the locals about possible air traffic like helicopters and crop dusters. If you are in a new area, you will need to know about ground activities as well. Make sure to check the weather forecast. Lastly, there can be challenges as it relates to frequency transmission, which could impact your drone and/or controller. Take the time to learn about spectrum analysis and what could cause frequency interference. It is always a good idea to check your compass to see if it needs to be calibrated. In summary, utilize crew resource management. Communication is critical. Using a FRAT makes risk assessment manageable. Utilize all resources available to you. Find ways to prevent emergencies. The use of checklists is the best practice. For questions or more information about this module, contact information is highlighted on the screen. This Assured Safe course was created in collaboration with NC State University.